I'm Karmel. I'm going to be talking about PANDAS, which assumes a little bit of knowledge of NumPy, so luckily we just did that. And before I start, I just wanted to give a little bit of a plug for IPython Notebook, which I'm pleased to see most of us appear to be using today. But if you don't use it, it's worth checking out, both for presentations like this, and also it's sort of, you can think of it like a fancy console. If you're doing lots of, module development, probably not great, but if you're like me, you're like, I want to try this and not spend forever doing it. It's a great way to set things up, and you can do plotting in line and all that good stuff. The HTML output of this notebook is available at this URL, so you can follow along, go there and follow along if you want. I'm not going to be typing real time like the last presentation, because I'm not that cool, but I will be, running real time. So that's a part of it. As mentioned previously, this is Python 2.7, and we're going to be talking about pandas. So the benefit of talking about pandas is you get to include cute pictures of pandas. This is one. Unfortunately, the display here is not live enough to show you the whole thing at once, but we'll do it as we go. And just to give you an idea of what I'm going to talk about today, the plan is to do a general tour of pandas. I don't expect that, after this you'll be able to jump in and use it, but I want to be able to show you what's possible, the basic data structures, what you might do with it, how you might use it, and then, some of the, hey, look, this is exciting, that you can go back and check later. A little bit about me, the obligatory vanity slide. I am getting my PhD in bioinformatics at UCSD. If you want to find me, that's my email address. I came to pandas because a lot of people use R in the bioinformatics field, and there are a lot of things that R is really good for and really fast for. But if you're a Python person, it's painful to use R. And so a lot of the beauty of pandas is it makes it so that you don't have to. It does a lot of the things that R is really good at, and it does it simply. A brief history of pandas. Wes McKinney is the main developer, and he's still the primary developer. He created it, still the main guy on it. He was working in R, he was a quant, so a lot of the functionality of pandas is designed for financial analytics and makes that sort of thing really easy. But the name is sort of a general approximation of something like pandas for numerical and data analysis, or Python, excuse me, for numerical and data analysis. You can see how you sort of get pandas out of that. It's still rough around the edges. It's still actively being developed. We're not even at version 1 yet, so you might find that if I'm going to be using version 0.10 here, and things sort of change every time, and you might have to go back and edit some code if you update to a new one, because it's not guaranteed at this point to be backwards compatible. And there are some things where you feel like, well, that's really non-intuitive, it should work another way, but all that said, it's a really good library, and I use it a lot, and I'm a big fan. That is a baby panda. It's very cute. But getting started, what is pandas for? Why do you need that on top of NumPy? And the basic idea behind pandas is that NumPy is great if you're working with numbers, and it does a lot of things really nicely with floats and ints. But if you want to have any other sort of data, or you want to work with anything that's not zero indexed, or you want to work with anything that's pretty for humans, it becomes very difficult very quickly to keep track of all of that in NumPy. And so pandas was designed to fill the gap between NumPy and the things you're actually doing in your in your job, in your work, in your domain-specific applications. So in Wes McKinney's case, that was financial data. In my case, that's a lot of bioinformatics and biology data. The basic idea behind behind pandas is that you take the NumPy array and you add labels. That's like the most basic application of pandas is going to be like, hey, we've labeled our NumPy array, and we've made it so that it's easier to hold mixed type data. So you can store, strings and do operations over strings and objects and all sorts of things that are sort of unwieldy in NumPy. It also has because it was built for financial analytics as a focus, there's a lot of built-in statistical stuff and a lot of built-in functionality for data analysis. And if you are in a domain that uses a lot of Excel, or you have people sending you Excel sheets and saying, oh, can you do some analysis on this? Pandas is your friend, because it will save you ever having to open Excel. You can just has a lot of built-in functionality to read in CSVs, tab-separated files, Excel, spreadsheets. It's also, I use it a lot as sort of a simplified database. I don't want to load everything into a bunch of different tables if it's a relatively small amount of data. It has some of that relational table-like functionality built in sort of a simpler format. The big promise of PANDAS, the big focus is taking all this data and doing analysis over it. So NumPy is very good with the numbers. PANDAS makes it a lot easier to actually turn that into something functional and meaningful, and a summary of that, let's say, for your specific needs. So with that, we can actually jump in. All right, so you can import PANDAS with a command line like that. As I mentioned, I'm going to be using the version of PANDAS that comes with the Anaconda package. A quick pitch for Anaconda beyond what was said earlier. It is actually maintained by Continuum Analytics. It is unlike the nthought distribution, which is free for academics and also a very nice, convenient install of all the Python plus scientific packages. Anaconda is actually free and free for commercial use and all of that. It's maintained by the people who now are doing Blaze and previously built NumPy and SciPy and all that stuff, and they're good people, so I'm a fan. The PANDAS library, some of the basic data types that are important. You can see them in the doc stream. We're going to be talking about series and data frames today mostly, but there's a lot of other stuff in there that you should check out if it's the kind of thing you use. We'll talk a little bit about the datetime functionality, but to start with, we're going to start with the series, which is sort of the most fundamental object in PANDAS. And basically, it's a one-dimensional labeled array. So you just heard about arrays in NumPy. This is actually an extension of the NumPy ND array data type, but it adds this feature called an index. And so instead of just having things zero indexed, or instead of having to reference things in that way, you can pass in names for your one-dimensional array. Also, you'll note that it's pretty easy with the series to add mixed data types, whereas it's a little bit more complicated with, or a little bit less convenient, let's say, with an ND array. Notably, these are mutable, and they are array-like, and they are dict-like. So you get lots of this built-in functionality that, it's sort of like a dictionary plus a list altogether. So how do you actually use it? You can import it just from PANDAS import series, and then you can create one from a list. There are a number of different ways to create it that are documented, but we'll start with the simplest, which is I've got this list of data. I'm going to create a series from it. And there you go. When you just do it that way with just a list, it looks more or less like a list. Here are the indexes. This is the index printed here, and you can see that it's just zero index by default because I didn't tell it to name anything. And it's got my various data types there. But we want labels because that's sort of the point. If you just wanted a list with zero index, I could have just made a list. So here I'm going to pass in my index. Again, this can just be a simple list of the names that I want things to be. And when I do that, it creates this new type of object, which is a series, and it has my data plus my index. And the cool part is that it's, first of all, it's array-like, much like all the things you just heard about with ND arrays, you can do with this data series, even though it's got mixed type data, right? So I can do list comprehensions, I can apply functions over the series, the sequence, and I can do all the standard functions like length and all those things that would apply to a list or an ND array apply here. So you can see that in the first line I've used a list comprehension to just multiply my different objects times 2, which in the case of a number it does that, but in the case of a string it duplicates it. You can join them just like you would a list or an ND array. You can count them. It's all nice and pretty and behaves like you would expect. You can index. So even though I passed in named indices, you can still use the zero indexed sort of default behavior. So if I want the second object, or I guess that'd be the third, it returns as you would expect the number that I passed in there. And you can take slices just like you would with an ND array. So that is, but here again, it comes back with the index. And you can even pass in as you would with an ND array, you can pass in the set of indices that you want, but instead of just being 0 or 1, you can pass in the names, which is a lot easier to keep track of if you're working with sort of data that's been passed in, human data. It's, I don't remember what I passed, I don't even remember from 2 minutes ago which columns month and rainfall were, so I can just pass in the names and get those back. And then again, much like an ND array, you can filter. So I want all the values greater than 0 from my series, which works quite nicely. In this case, that's all the values except the 0 and the none that I passed in. And filtering, we'll see later, works with data frames as well and is very useful for a number of things. But, again, all that would have worked with an ND array. So why is a series special? Well, it's also dict-like. So you can pass in keys by name. Again, much easier than remembering the indices or the order you originally passed in the data for. So if you're working for, in this case, weather data or with financial data or whatever kind of data you're working for, your code suddenly becomes much more readable and you're not tracing back from the beginning, what column was 0, what column was 10 that I passed into my ND array. You can actually give things names and strings. And much like a dict, you can iterate through, instead of iterating through the keys, you can iterate through this property called index, and that will return to you the keys that my series has, much like a dict. And you can actually, these are just some of the other ways you can create a series. We show the list initially. It can be created directly from a dict. It can be created from scalars, much like an ND array, range. It all works just like you'd expect, which is nice and convenient. All right, so that's the series, which is the one-dimensional structure. Now, if you taped a bunch of these together, you'd have a two-dimensional structure, and this is where you start to see the real value of PANDAS, right? So one-dimensional structure, that's great, but what we really want is a two-dimensional labeled array, at least multi-dimensional too. Because this, you'll notice, looks a lot like a spreadsheet that you might work with a lot, but hate opening Excel for. And it's also, it's like a DB table, right? So this is how a lot of our data looks. So it's really nice not to have to rely on, in NumPy, if you wanted something like this, you could create it, but it's not easy. PANDAS makes it easy. The name, by the way, comes from the R data frame, if you're familiar with that. They sort of, that's where a lot of this idea comes from, and a lot of the syntax came from R, but prettied up for Python users. It can be treated basically like a two-dimensional NumPy array in a lot of ways, or a matrix. Again, it's mutable. It's easy to add columns, and we'll go through that. I think in theory it should be easy to add rows. It's not at this point easy to add rows and like you can merge them and append them, but it's, I don't know, the syntax from that I imagine will develop because it's not simple right now. But again, you can see mixed data types that can be either, even within a column or a row, you can have mixed data types. In this case, we're looking at strings and floats and ints. And again, you can import directly from the main Python's package. And there are a bunch of different ways to create a data frame. The simplest way is to literally tape together a bunch of series. I guess that's not literal, but figuratively tape together a bunch of series in dict. So if I wanted to recreate this structure that I made up here, I just pass in a dict with the column names as the keys, and then a series as each of the values going down the column. So if I pass in that dict, I get back the data frame that we saw earlier. You'll note also that this pretty printing feature is built into IPython Notebook. So it knows how to print out data frames as little tables like this, which is super nice for presentations like this or displaying data to other people. You'll note that you can pass in with the series an index if you want it to be something other than the default 0, 1, 2, 3, 4, 5. In this case, that works for our purposes. You'll note also that I passed in, for this C column, I wanted a null value for the first row, and so was able to pass in the indices for the shortened list, and it automatically aligned everything such that I get my null value where I want. You can also create it from a NumPy array directly. So this is basically just a NumPy array with names on it, so it makes sense that you'd be able to, in this case, the default is, if I create an array and just wrap it in a data frame, it's going to automatically assign zero-indexed label names to it. But I can also do it, let's say I want a NumPy array and I want to take that and I want to make it with labels that I can refer to with names. In this case, you can pass in the labels, the index as a list, and the columns also as a list. So if I do that, I created a random NumPy array. I named my columns, I named my indices, and voila, I've got this very nice table that I can refer to now instead of just zero indices, but by name. And much like a NumPy array, again, we saw this with series, but you can slice as you'd expect, right? So we saw earlier, if you take the :3 slice of a data frame, you'd expect the first 3 rows, and indeed, that's what you get. Now, in theory, if this were a NumPy array, I could pass in just 3 and it would give me the 4th row. Doesn't quite work in Pandas. I think it should, but as it turns out, that will return an error because it looks for when you pass in just an index, it's going to look for a column. So in this case, it would work to say the my column, and it's going to return to me that whole column as a series, you'll note. So the column itself can then be treated as everything that we did with the series could be done to this column, but we refer to it by name, which is super convenient. And notably, if you grab more than one column of a data frame, it's going to return to you a data frame. And if you grab more than one row, it's going to return things as a data frame. So you can do anything you can do to the main data frame, to these slices and subsections. If you want to access rows directly, you can do that too. But instead of passing in directly to the brackets, you're going to pass into this object called .ix, which presumably stands for index. So here I want the second row. And so it's going to return to me as a series the row with all my column names built in as the index. And so you can, of course, string these together. Let's say I want the data frame that is made up of these 2 columns, and then I want the rows that are A and G. I can do that and just take the subset of that whole data frame and do any operations I want over that subset. And yet it's still ND array-like, so all the things that you know to use with NumPy and with arrays still work, as long as, of course, it's going to try, and if it runs into problems with the type of object you loaded in there, it'll raise an error. But in this case, we've got numbers, so I can take the transform, I can do a dot product, and it returns to me what you would expect if this were just a normal NumPy ND array. So that's the basic data structures, series and data frame being the 2 most core structures in the Pandas library. So the question is, what can we do with them? More cute pandas. So, I believe there was a data set passed around at some point. So I'm going to be working with that data set, which was the S&P historical closes since like 1950. The first thing you'll note, Pandas comes with built-in functions to read in CSV data. So I don't have to parse anything, I don't have to do any of that. Read CSV is going to read in a CSV. So I'm going to set that, it's going to read that into this object prices. If I look at the head, the top 10 rows of prices, hey, look at that. It's loaded it in as a nice data frame. It automatically parses the columns and assigns those labels as the names, and then because I didn't pass in any special index, it's going to zero index those. You'll note, though, that this first column here is a date column, which right now is read in as a string. The other ones it was able to tell are floats, but this it just interpreted as a string. But let's say I want that to be actual dates, because you may as well get the date functionality of Python if you're going to be using dates. So you can actually, because again, Pandas was built for quants, it has a lot of time series functionality built into it. So here you can just tell it to parse the column date as dates, and it's going to actually do that. And now this is a Python date time object and can be treated So what can you do with this now that it's a data frame? There's a lot of built-in statistics to PANDAS. So let's say there's this function called describe that can be called on a series or a data frame. And what that does is it's going to generate for each column, it's going to give me the count of rows, right? So there are 15,899 rows in the data set I read in. It's going to give me the mean, it's going to give me the standard deviation, min, it calculates quartiles, max. So that's just with this, one built-in function describe, and it will do that for each column. You can also do that for each row pretty easily. And you can call each of these functions. So you could call mean, you could call count. It will automatically calculate those for you, either row-wise or column-wise, or over the subset of the data frame you select. You can do sums, skews, kurtosis, all sorts of special stats functions are automatically built in. And you can do this row-wise as well. I don't know why you would want the mean of each data, or the data row-wise in this case, because they're all different types, but let's say you did, then it would give you the mean for each row by passing it this axis equals 1 parameter. Whereas the default is 0, which gives you column-wise data. And again, much like NumPy, because this is built on the NP array, you can apply functions and broadcasts and everything you heard about you can do, but now you can do it with labels and with the mixed type data that you have. So let's say I want to create, so here I'm going to create a new column. As I said, it's easy to add on columns. I just, like I would a dict, assign a new key there. So I'm going to create this column range, and I'm going to say I want that to be the high minus the low in this prices data frame. Now this is basically, if you can imagine it, taking the high column, subtracting the low column and doing it row-wise, and returning each of those values into this new column range. And then I can take the head of that, I can describe it. You can see that it's going to give you the values row-wise, and I can see pretty easily, oh, it's going to calculate stats for me on this series I just created. So again, there's 15,000 of these, and the mean is 5.75, standard deviation, etc. The max 110. I'm going to guess that was sometime in 2008, but I don't actually know that. And much like with the ND array, you can broadcast and run all sorts of functions. So here, I'm just going to take the open and close. So I'm going to take this slice column-wise of my data frame, and I'm going to square all of those, just in case you wanted to. And it does that quite nicely with great ease. So let's say I actually wanted to do something. Let's say I wanted to calculate how many up days there were, how many down days there were, and how many even days there were. This is, I'm not a financial person. This is my naive interpretation of what people do with financial data. So the naive way to do this is to go through and to iterate row by row and figure out, okay, was it a good day, was it a bad day, was it just all right? And so with pandas, you can iterate row by row. There's this function iter rows, and there are a number of other similar functions depending on what you want to get back. This will return to you the index, which is like the name for the row, and the row itself. So if I do that, I can go through with each row, and I can say, well, is the open less than the close? If so, that was a bad day. If we went up during the day, then, just realize that's backwards, isn't it? Open is less than close. Well, this isn't the evil version of the world where you wanted it to end. I'm shorting all stocks, let's assume. So if open is less than close, it's a bad day. If open is greater than close, it's a good day. Switch that over here. And if they're equal, then it's okay. So I go through row by row and do that, and I get my values. So 6,000, 6,000, and 3,000 that are even. But let's say, you know what, we've got this data frame. I'd like to do this without a for loop because that seems sort of unnecessary. So one of the things you can do with a pandas data frame is you can apply a custom function. And you can do this row-wise or column-wise. So let's say I want to define my custom function. I want to evaluate the day. I calculate what the change was. And if, so here I'm going to return for each row, I'm going to run this on each row. I'm going to calculate the change, much as I did up here. And then I'm going to return, if the change is non-zero, then I'm going to return either 1 or -1. And if it's 0, then I'll just return 0. So I'm going to run this. I'm going to assign a new column here again. It's going to be called day quality. And I'm going to use this function apply. And that's going to go through, it's going to go through my data frame. Axis equals 1, again, is row-wise. And so it's going to apply this function and pass in the row to evaluate day each way. And then I'm going to call value counts, which is another built-in function, and it's going to basically give me a histogram. For each value that is in that column, how many are there? And hey, look at that. So we've got 6,000 good days, 6,000 bad days, and 3,000 that are just even. So that was another way to do the same thing without actually having to iterate through. But maybe we don't need to do this row-wise at all, right? So it seems again that I didn't have to iterate through, but I did have to apply a function to each row, and it seems like we should be able to use the fact that this is an ND array data type to calculate these values. So here, I'm going to create a new column. I'm going to call it change. And so I'm going to store the close minus the open in this column change. So it's going to get tacked on to my data frame. And once I calculate that change, I'm going to go through and calculate the day quality based on that change. So if change is positive, then it will give me 1. If change is negative, it's going to give me -1. You'll note here that the absolute value call, which is right here, is actually pulled directly from NumPy. Yes, David?
Would that divide by 0 on days where they're exactly equal?
Good question. It's almost like you're reading ahead. Hold that thought. And then I'm going to do my value counts, right? And as you suspected, hey, I get my 1s, which was correct, and I get my -1, but 0 seems to be missing. What happened? Well, let's inspect. We can just take day quality, and we, of course, get not a numbers because we've been dividing by 0 that whole time. So, PANDAS has a bunch of functionality to handle null values, which can be read in either as blanks or zeros. The simplest thing to do is to fill them with a value. So in this case, I'm going to fill in with 0 because I know that if I was dividing by 0, that was a 0 day. I want my day quality to be 0. So I can just fill, and then we get the answer I wanted all along.
Being fastest for doing all of that.
Fastest? If you're thinking about fastest, you shouldn't be using PANDAS.
Really?
I mean, consider that a lot of the value here is these labels, and so if you wanted to do it faster, you go down into an ND array. I'm going to get to my favorite way to do it in a minute here with the filters, which probably is also the fastest, I'm guessing, but I haven't actually checked. But this is a lot of structure over the top so that you can do things that are human readable. So much like ND arrays and much like we saw with series, you can use data frames to filter. And this is often a very, very useful feature, and it's something that's difficult to do with ND arrays. There's a lot of functions you've got to call over it, and you lose track of what your different columns are, but it's super simple to do in PANDAS. So let's say I've got my prices array, and I want all the places where the change column is less than -75. All I have to do is this one line, and it's going to return to me all the rows with all the columns where the change is less than -75, which I guess is only 1, 2, 3, 4, 5 of them. And you'll note that it returns it as a data frame, so I could then take only that subset of data and use that for whatever subsequent analysis I wanted to do. Notably, when you're doing a filter like this, basically what it's taking in is a Boolean and then applying that row-wise and returning to you the rows that are true. So if you were to look at, I want all the places where my range is greater than 5, this right here is going to return to you a series of Boolean values that you can then use to filter that prices data frame. And notably, anything that returns a Boolean here, I'm just going to do even odd, is going to do the same thing. So the nice way, often what you find yourself doing is filtering on certain columns, but whatever arbitrary Boolean values you wanted could be used. So in this case, you can see that what's returned by a truth value or a truth statement like this is Booleans, and if I just want the even and odd, I can do that too, and it'll return the odds. based on that Boolean I had set. So, as I said, you get data frames returned. So if I want all the places where the volume is greater than 1 billion, and then I describe that, it'll return only that subset of data. It'll do everything that the other data frame was able to do, give me the means and standard deviations, etc. You can also filter across multiple columns. So if you wanted all the places where the range is equal to the change, you could do that. And again, you can imagine this is basically creating a Boolean column-wise and then applying it to data to your data frame. So that returns our 3,000 places where my range is equal to my change. You can chain multiple filters together. So with and or logic, singular here. So if I want all the places where volume is greater than 6 billion, but also the change is negative. So all the down days with really high volume, let's say, there are only 84 of those. And if I didn't have this length here, it would actually give me the actual data frame with those values, and I could subsequently analyze them. Notably, we read in that column as a date, and we can actually use that to filter as well. So PANDAS plays nicely with dates, which is really convenient if you're working with time series data. So in this case, I'm going to I only want the data for after March of 2013. And it's going to return to me just that set of data, all 6 values since March of 2013. Which brings me to my favorite way to count the good and bad days, is to use filters, right? Where I want all the places where the close, I'm going to create a filter here. All the places where close is less than open we'll call bad. And again, this is returning a Boolean, so I can just take the sum of that, where false evaluates to 0 and true evaluates to 1. So it's going to assign that, it's going to sum those up, give me bad days, do the same for good, and the same for mediocre days. And there you go, you get that with a nice, really clean bit of code that is obvious to any reader what you're analyzing, why you've assigned that, how that's created, and it's easy to interpret and write. So, finish up here. I'm going to go through quickly just some of the fun a few tricks that I'm not going to go into detail about, but if it's the kind of thing you use, you should definitely check out. It's all well documented. The first is time series. I mentioned them a couple of times, but you should note that scikit's time series is actually being closed down, and all that functionality is being moved over to PANDAS. So a lot of the stuff that used to live in scikit's time series is now being moved into PANDAS, which includes lots of fun date stuff. And if you've ever had to build like a Gregorian calendar by hand, you hate them. And so this is very nice. You can do, create date ranges very easily. It can interpret a string, which is awesome. And then you can do things like, I want it to start here, end here, at this frequency, and it'll return that set of timestamps at that frequency for those dates with great ease as a series. You can do it for duration. So let's say I want 48 of them every 30 minutes. It'll do that very nicely. And you're able to use dates. So if you use dates as an index for a data frame, you can then do all sorts of fancy time series stuff in the PANDAS library. So here you can see that I've now named each of my rows with some date and generated random data to fill that. And so let's say I then took that data frame, I can resample it. So that was every 30 minutes. I really only want the hourly data, and I want it to, there's a whole bunch of different ways you can have it compress the data and resample it. Here I'm saying give me the sum. You can do mean, you can do all sorts of different statistical functions. So here it's going to spit back out, hey, I'm only giving you the hour points, and I've summed up all the values in between, which is much more convenient than doing it by hand. It's got all sorts of time zone functionality, which automatically builds that in, which again, if you've ever actually had to adjust for time zone, is great, because that's obnoxious to do. And I mentioned you can use PANDAS like simple relational tables. I wouldn't try to load a ton of data in there. You know, there's some point where it stops working very efficiently, but I've done it with like 50,000 rows, and it works nicely. I've got a lot of RAM, but you know, I've never tried it on a smaller machine. Again, usually when I'm using PANDAS, I'm not doing it for efficiency's sake. I'm doing it because it's easy for, you know, an application. But you can do things like group by. So I had my prices data frame, and I had these day quality values that were either 1, -1, or 0. You can group by, let's say I want to group by the day quality. PANDAS will do that, and then it'll return to you, basically it's a set of tuples where you get the value, and then the group, all that's as a subset, the data frame that have that value in that column. So you can see here, if my group I can iterate through, I can get, for the -1, it's going to return to me, you know, however many rows that was, plus 0 and 1, and so I can group by and then just operate on that subset, or that the subset of data that has that value. And let's say I wanted to pull in other types of data, right? So here I'm going to pull in some Forex values, so the daily change in US dollar to euro exchange rate that I downloaded from here, if you want that. I'm going to pull that in again. I am going to just use this read CSV function. I'm going to tell it to parse this date column, which I know is all caps date, and it's going to do that. And so I've got this date, and it gives me a value, which is the change in the exchange rate from the dollars to the euro at that date. So the first thing I'm going to do with this data is I'm going to clean it up a little bit, because you'll note here these all got interpreted as strings because the first value they sent was in that file is actually a string. So I'm going to write a function that's going to try to create a float out of the value, and if it doesn't work, it's just going to say, ah, that's 0. I don't really care what it is. There might be a more appropriate return value for this. Again, I don't do financial data, so I'm going to assume it's 0. And I'm going to rename some of my columns. I'm going to rename my all caps date to the date so that it matches the one I already have in prices. And then I'm going to create this new column that is the value column, but converted to a float with this function I defined. And I'm going to run that, and then I'm going to drop the columns that I no longer need. Now, you note that up till now I've been saying that if you send access equals 1, that should apply things row-wise. With drop, for some reason you have to say access equals 1, and then it'll drop the columns. I don't know why that is. I can't tell you. You can imagine that maybe they mean for those columns, drop each of the rows. I feel like that should be access equals 0. Whatever. But now, so now I've got this nice set of data. I've got this nice data frame where I've got a date, and I've got my float value. And what I'm going to do with this is I'm going to take my prices, and I'm going to merge this new data frame, Forex. I'm going to do an inner merge, or inner join, basically, which, if you're familiar with relational database logic, means only give me back the values for which I have data in each of my 2 tables, or each of my 2 data frames. And I'm going to do it on date. So it's going to take this Python's date object, and it's going to match them up in my Forex data frame and my prices data frame. And it's going to return to me the values that exist in both. And you'll note that it's going to take a second to do this. And there we go. We can see that I get a subset of the data back, and I've got all the original columns that I had in my prices, but now I've got this new column tacked on, which came from the other data frame that I just merged with it, and they're all lined up by date, which you can imagine is super useful for all sorts of things. And we're going to hear about matplotlib in a moment, but there's also some built-in plotting for data frames. So if I call, so this is the joined data frame I just created, and let's say I want to see, hey, is there any correlation between the change in the S&P and the amount, or yesterday's US dollar to euro change? The answer is not likely. Looks pretty much random, which is probably a good thing for us. But you'll note that this was as easy as passing in an X column, a Y column, and calling this built-in plot which is a function of my data frame. Also, time series stuff. It knows how to graph things by times, or by the date. So if you just call plot and then you pass in as the x column, or as the x-axis a date column, it's going to do that automatically. Now you notice, if you know anything about the stocks, you look at this and go, wait a minute, that doesn't look good for us. And it took me a minute to realize what was going on here. But so PANDAS is smart enough to recognize that this is a date column. And so it's going to say, if you look back up here, just because of the way the data was read into the CSV file, it's going backwards in time. So PANDAS is smart enough to recognize, that those dates are backwards, I want to flip those, but not smart enough to know to do that to the Y column I passed in too. So it flipped the X, it flipped all the dates, but not the closes, so this is actually backwards. But that's okay, that's easy to fix, conveniently enough. I can just take my data frame, sort by date, which again, because these are all actual Python date time objects, it's easy to do. Then I can plot again, and hey, that looks a lot better for us. So yeah, that's it for now. But I don't know where these pictures are taken. If you want more information, this is all pretty well documented. Not perfectly documented again because it's developing and it's mostly West McKinney, but it's pretty well documented here. The code is all available on GitHub. There is a book recently published, a whole big fat O'Reilly book by Wes McKinney. It's about Python for data analysis generally, but obviously there's a lot of focus on pandas because he wrote pandas. You can get it there. He's also around and he's available. He just moved to the Bay and is starting some quant company, but he's on books. IPython Notebook does markup. And then there's other things. There are a bunch of videos from the various PyCons that are pretty good and will give good intros done by Wes McKinney. Stack Overflow, of course, and that's all. Questions? Yes?
Do you know if you can join with a hierarchical index?
Pardon?
If you have a hierarchical index, like a composite index, can you join with it?
So it does do multi-indexes, and it does. It also has pivot table functionality, which I guess is the name borrowed from Excel. I'm not actually sure what that is, but I know multi-indexes where you can actually do essentially what would be like a 3 or multi-dimensional data structure in Python. So it does do that. I stuck to the 2-dimensional here, and actually most of what I use is 2-dimensional, so that's what I can answer questions about, but it does do that. Yes?
Do you know if there's anything built into PANDAS for doing principal component analysis?
I think there might be. I'm not sure. I know that, so what I've used for things like that is the scikit-learn package, which has a lot of machine learning and sort of PCA, all that nice functionality built in, and that plays nicely with pandas. I'm not sure if pandas itself has PCA built in, but it is also, these are ND arrays, so you can always pull it back that way. So it might, I'm guessing it doesn't actually re-implement that, but it does play nicely with the other packages that do that. Yes?
Since it's sort of like a spreadsheet library for Python, is there a way to put inside a cell a reference that refers to like a formula from other cells and have pandas evaluate that only for special cells that have these formulas?
I don't know if you can store, I've never seen it stored as a function, but I can, anything is a Python object,
right?
yeah, so
you could somehow mark it or detect it's a formula and then run an eval function on it by just putting it automatically.
Definitely, and you can always do what I did a lot of was basically assigning a new column with that value calculated out, but in theory you could store a function there just as easily, and then, Yes?
Okay, so if you're doing aggregate operations on multiple columns at once, is there a better way to do it than just, like resampling each series and joining it back onto a data frame? So I know he's got some convenience functions that do some canned operations and output a data frame with multiple columns, but it seemed kind of tedious to do your aggregation on each column, on each series at once, and then put them back into the data frame.
You mean?
So if you needed the min of one series and the max from another one, and the average from another one, all that thing.
there is a way, there's
Yeah.
syntax to basically tell it, you know, for this column I want min, for this one I want max, for this one I want sum. So there is, yeah, you pass in like a list of what you want with the index.
But can you do that like while you're resampling?
While you're resampling? You mean like, oh, I don't know. Maybe.
Okay, I just
I've
wanted to
never
see.
tried, but there is definitely functionality to do that, to pass in different operations for each column, so there might be. Yes?
Yeah, have you played around at all with RPi? And
I have not, because as soon as I found pandas, I was like, I am never using R again. So I just changed my matplotlib, matplotrc, so that it looked like R, and
Yeah.
I was happy.
but you know, R is a lot more developed, and you know now with the with the Python interface, I was wondering if you get any reference for comparison. I actually did see in the website at some point that they were trying to do kind of an interface between pandas and one of the RPi versions. I think it's RPi 2, I think.
Yeah, so I know that they are, you know, that, I mean, Wes McKinney started in R, and he, you know, so a lot of the people who use one use the other. There's also, I know that he also maintains stats models, which is a lot of sort of more, you know, fancy statistical stuff, and I know that that also talks with R to some degree, because R does a lot of stat stuff very nicely. So I think that that is something that's sort of baked in to some degree.
Can you show me the link to this?
Thanks. If you have questions on Karmel, I'm easy to find.
Thank you. The food has arrived, like 2 minutes ago, but it's still hot. I have not yet discerned which one of these is vegetarian, but I am told that one of them is. Other than that, I would like to